magnetic field due to a long straight current carrying conductor. So as we are earlier studied that by the Oersted experiment, the current carrying conductor has a magnetic field. By using a Biot-Savart law, we determined that the magnetic field value, that is the expression for the magnetic field due to the current carrying conductor, is dB, which is equal to mu naught by 4 pi IDL sin theta by r square. So now we are going to derive the expression for long straight wire, the current carrying conductor. What is the magnetic field around it? What is the magnetic field expression? So according to Biot-Savart law, dB is equal to mu naught 4 pi IDL sin theta by r square. This is a straight wire XY. So the current I is flowing from the south to north direction. This is a small elemental length DL. From the point O, there is a line joining the at what point the magnetic field is going to determine. So we are going to determine what is the magnetic field at this point. So that is our question. So from this point, we are joined this point, that is angle theta. So this line, if you draw the perpendicular line from the point P to the current carrying conductor, meet at a point Q. So this will make an angle 90 degree. This is an angle theta. We will give the name for this angle is pi. Okay. So the angle OQP, angle OQP 90 degree, theta degree, and pi. So theta plus pi is equal to 90 degree, because in a triangle the total sum of the angle is equal to 180 degree. So theta plus pi is equal to 90 degree. Theta is equal to 90 minus pi. So if you substitute this theta in sin theta, what we will get? Sin theta, which is equal to sin 90 minus pi. Sin 90 minus pi is equal to cos pi. So what we are going to do means, this is the Biot-Savart law. We convert all the terms in the Biot-Savart law into our question. So sin theta can be expressed as cos pi. Then what is the cos pi? Cos pi is adjacent side by hypotenuse. So this is a pi. Okay. This is an adjacent side. This is an opposite side. This is a hypotenuse. So cos pi is equal to adjacent side by hypotenuse. That is A by R. A by R. Then R is equal to A by cos pi. If the cos pi comes to numerator, A secant pi. So R is equal to A secant pi. Instead of R, we are going to substitute A secant pi. Similarly, tan pi, which is equal to opposite side by adjacent. In order to calculate the length, because there is a DL term is there. So this length is a from O to Q is a length will be taken as a L. So what is a tan pi? Opposite side by hypotenuse. Opposite is L and adjacent. Tan pi is a opposite side by adjacent. So opposite is a L and adjacent is A. So L is equal to A tan pi. Differentiating the L, we get DL, which is equal to A secant squared by T pi. So we are differentiating left side with respect to L and right side with respect to pi. So L is differentiated as a DL and pi is differentiated as a d pi. Tan pi is equal to secant square pi A as it is. What we are going to do that? This is the Biot-Savart law, which explains the magnetic field of the current carrying conductor. So for a straight current carrying conductor, we are going to substitute this sin theta value here, and this R value here, and this DL value here. We obtain the expression. So very simple, students. Write the Biot-Savart law and convert this Biot-Savart law into our problem. Substitute the value, we get the expression. So next we are going to substitute all these things in the Biot-Savart law. By substituting the I, DL value is A secant squared by T pi, and sin theta value is of cos pi, and R value is A secant pi, that is R squared means A squared secant squared pi. So secant squared pi get cancelled, and 1A, and here the A will be cancelled. Denominator we have A. So mu naught by 4 pi A, I will be there. So mu naught by 4 pi I, then this A will become here, then cos pi into d pi will be here. So that is for only for the small elemental length. For integrating, if you integrating, we get the magnetic field for whole entire length. So integrating dB, we get B. Integrating, you are taking the common terms outside. That is a constant terms outside. Mu naught by 4 pi IA will be taken outside. We have only the cos pi d pi. Listen students carefully. Only the pi values change. If the pi values change to, that is the pi 1 value, the angle between the this horizontal and this x value is pi 1. This is a pi 1 and this horizontal to upper end is a pi 2. So this is a pi 1, this is a pi 2. This is will be taken as a horizontal, lower end is a minus pi and upper end is a plus pi. Again I will say that this is a horizontal. The angle from the point P to the lower end x is, what is that? Pi 1. Then the angle between the point P and the upper end y is pi 2. So the pi 1 is negative because we will take it this as a horizontal. So this is a negative, this is a positive. Lower limit is a minus pi 1, upper limit is plus pi 2. So then only we are able to get the long straight wire magnetic field. For the whole length we are able to calculate. So integration is a very important tool for doing this calculation very simply. Yes, by substituting the limits minus pi 1, pi 2. So what is the integration of cos pi? Integration of cos pi is a sin pi. So substituting the lower upper limit and the lower limit. So sin pi means sin pi 2 minus sin pi 1. That is a minus of sin pi 1. This minus will be come out means it will become positive, that is a plus. So what is the final expression? B is equal to mu naught I 4 pi a sin pi 2 plus sin pi 1. What is the pi 2 and pi 1? Pi 2 is that is a upper end angle and pi 1 is a lower end angle. This is a horizontal. For the two, if it is a, this is a straight line, so we have to take it that upper end angle and the lower end angle, we get the total magnetic field of the straight wire. So very simple, students. Okay, now we are going to see some special cases. For the first one, for a infinite long conductor, if the P lies in the middle of the conductor means, what is that? P is in the outside, if it comes to the middle, then pi 1, pi 2 will become 90 degree. So if you substitute 90 degree in the sine pi 1 and sine pi 2, we get sine 91. 1, so 1 plus 1 2, we get mu naught I by 2 pi a. So this 2 and this 2 get cancelled. Then if you can take that xy is infinitely long, but P lies nearer to any one end of the end. That means not in the middle. It may be at the top or it may be in the bottom. So it may be in the any one of the end means any one angle will become 0 and one angle will become 90 degree. By substituting the same thing sin 90 degree and 0 degree, sin 0 0, we get mu naught I by 4 pi a. So if it is the point lies in the middle means mu naught I by 2 pi a. If the point P lies in the any one end of the upper end or lower end, it will become mu naught I by 4 pi a. Then very important thing, if the conductor is finite length means L. So L length and P lies is perpendicular to the bisector, exactly bisector. So above the length is L by 2 and below the length is L by 2. That is the thing. So the point P exactly in the middle. So the total length is L. So the middle this is L by 2 and upper angle also L by 2. This is also pi. This is also pi. Both angle is same. So what we are getting, sin pi which is equal to opposite side by hypotenuse. So what is the hypotenuse? Root of a squared plus L by 2 the whole square. So this is the hypotenuse value. This is the adjacent value. This is the opposite value. So sin pi which is equal to opposite side by hypotenuse. So L by 2 comes to the down. So by simplifying we get an answer sin pi which is equal to L by root of 4a square plus L square. Yes, students, what we are going to do that? Substituting this value, B is equal to mu naught I by 4 pi a. So sin pi both will be a pi 1 and pi 2 will be a pi. So here 1 pi and here 1 pi. So it will become 2 pi. So 2 sin pi. 2 into sin pi value L into root of 4a square plus L square. By simplifying these equations, we get an answer mu naught IL by 2 pi a root of 4a square plus L square. So very easy question. So for infinite long wire, so we are derived the expression this one. But for that different cases, first case is exactly in the middle of the conductor, but very closer to that. It is very closer to the middle of the conductor. Second one is at the top or bottom of the conductor. Then third one is we are assume that the conductor has a finite length of length capital L. So for that the magnetic field is this one. Again I will recall you, the direction of the magnetic field can be determined by using right hand thumb rule. If the current is going like this, what will you have to do that? The right hand thumb rule. This is the upward direction, so it will be comes like this. So the right hand thumb rule, we have to use that. So this is a very easiest question. So the magnetic field due to the long straight current carrying conductor, we have to draw the diagram for a long straight carrying conductor. Substitute these values to the Biot-Savart law. This page is very important. If you remember this one alone, it is very easy for you to solve this or to derive this question very easily. I will upload the soft copy as a PDF in the Google Classroom. So you may copy from this PDF also. Thank you, students.